see some applications of resonance. One such application, let us see. If a compound is showing the acidic property, there are two clear-cut observations. One is why this compound is having acidic. This is the called reason. What is the reason to show the acidic property? This is the one such the aspect. The another aspect is when compared with other compound, is it showing the little stronger acidic property or weaker acidic? That is comparison. So if I say acidic property, there are two different aspects. One is reason why it is showing. Second one is comparison with the other compound. So first reason we are searching here. It is the acidic property or acidity of carboxylic acids and phenols. These two compounds let us examine. I take formic acid. Now formic acid, if it gives a proton, right? So it is giving the proton, taking the 2 electrons to the oxygen, it will become a formate anion. Formate anion plus proton. So the proton giving property is ready for this formic acid. Formic acid has a favorable that is a situation to give this proton and the formate ion. To form formate ion, it shows readiness. Why it gives the proton so quickly means the formate ion has a beautiful resonance. Why I am saying beautiful means the other resonance structure is equally stabilized. So this side you will get double bond, that side you will get the minus charge. So the same type of another, so 50-50 contribution. How much this is stable? It's a resonance structure, another structure is also equally stable. And here we have one plus point. What is that? If minus is rich, it is want to donate, and this double bond is always, it has an internal that push is there from this side, pull is there from that side. It want to donate, it want to take. Just like I have a that is internal desire to donate money, the other side person has a internal affinity toward the money, let us say. Now these two combination will have a transfer of money readily. Like that this O minus has a tendency to donate because it is minus charge is a problem, it want to donate it. And the C double bond O is having a original polarizable quality, therefore it want to, even if it is not there also it want to polarize. So if it want to give, immediately take a chance, and then that's it. Now this side will be pulling, that side will be donating. Again the same situation. When once that accepts, that will become excess now. Now this will take. Now once this side becomes excess, that's it. Like that the cloud will be, minus charge will be going this side and that side. There is a push and pull effect is there. Therefore the fast resonance will takes place. Number of structures will be actually 1 plus 1 only. But this resonance is an excellent resonance and having 50-50 contribution. It is actually a no charge has become into a charged structure, isn't it? So this charged structure is going on. So what type of resonance and all that, if you see, there is a minus charge, so there is a pi bond. So pi charge eligibility. So when you write resonance, you must be aware of the 3 points. One is it really allowed resonance? Pi and the charge is there in the conjugation, therefore it is showing. So this is allowed resonance. Second one, is it the according to the richness of the electrons flow is correct? Yes, minus charge is giving, so therefore it is taking, isn't it? Minus is rich than the pi bond, so minus is donating, pi bond is receiving. Just now I said minus is rich, so from richness to the less side it is going, so it is allowed. Again it is rich and this is pi bond, so minus is giving, pi bond taking, so it is allowed. The third one is what type of resonance, is a grade 1 or grade 2, grade 3. It is charge is there, charge is there. So therefore charge is delocalizing. Charge delocalization will be the grade 2 type of the resonance, or you can call it as a technically it is a charge delocalization resonance. Now if the question is why the formic acid gives readily proton, that's a straightforward question. Answer also should be straightforward. Its anion has a resonance stability, that's why it gives proton and becomes a resonance stabilized anion. Now the question can be made into little complicated also. If somebody asks, do you think that the formic acid has no resonance? No, it too has a resonance. Where is the eligibility? There is a pi bond and the 2 lone pairs are there, isn't it? Oxygen is having the 2 lone pairs. One of this lone pair can donate and show the resonance. This formic acid itself has a resonance. Now what is the resonance structure of this one? O will become minus. This side you will get a double bond and a hydrogen. Only one lone pair, a positive charge is formed. Even the formic acid has a resonance. Now the question, if it is repeated in the other way, when formic acid is also having a resonance structure, then what is the fun of giving the proton and showing the resonance? If that litigant question is asked, now you must be very careful to differentiate the what type of resonance. That resonance is a grade 2, that is charge is there delocalizing. This resonance is a grade 3, that is what is that grade 3 I said? No charge is becoming into separation. This is not that good. So a person is having a grade 3 job, he has a right to upgrade to the going to the grade 2 job. Like that, this resonance has every time definitely it will have a the tendency to change its type of the or the quality of the resonance. It is already having a resonance, no doubt, but this resonance when compared with that resonance is a inferior type, that is the better one. So therefore always a better or the upgradation is taking place. So why the formic acid is giving means you can say little complicated answer. Formic acid is also having a resonance, but if it gives a proton, becomes a formate anion, can show the better type of the resonance. Therefore formic acid is giving the proton and becoming into the formate ion and able to show the grade 2 or the charge delocalization resonance. This is charge separation resonance. No charge has become plus minus resonance. Okay. So therefore, and here also, and this side will be the more tendency will be there, this side will be less tendency will be there. Okay. If let us say this is treated with the sodium hydroxide, then what happens? You will get a sodium salt here, okay, or sodium salt here. Now these two structures are equally contributing. So therefore, the double bond nature between the CO and this side, sometimes double bond is that side, sometimes double bond this side. So therefore the bond lengths between the CO double bond and the CO, this side and right side and left side, let us say the bond length is same, because actually double bond should be shorter and single bond should be longer, but within no time the double bond is a single bond will become double. So therefore net will be that like this. A formate anion will have a sometimes that side double bond, sometimes this side double bond, and the charge, that is and the minus charge is sometimes that side, so we write in between. So this is called what? Resonance hybrid structure, in which the C double bond, both the sides will have some single bond nature, some double bond nature. It is not exactly single bond or double bond, in between the double and single. So therefore the length of this bond will be shorter than the single bond, longer than the double bond, and shorter than the single bond, isn't it? So single bond should be long, but it will be little short because it has some double bond character. Is it exactly double bond? Means no, it has a single bond nature also, therefore little longer than the pi bond. So here the equal length, that's why either you measure this side or that side, the bond length will be identical, but in this case it is not there. The double bond is shifting from one side to this side to that side here, but this contributes more structure, more time one side double bond is there. So if you want to write a resonance hybrid of this one, so there will be a double bond there, so more double bond will be this side, so I will put the dots more here, and this side I will put the double bonds far away. Okay. So this is the resonance hybrid structure. So double bond in nature towards this side will be less, that side will be more. So therefore there is a difference between that O and this O. The bond lengths are not identical. This was asked in once in a IIT exam also. When I take sodium formate, the bond lengths between the double bond and single bond is identical, because sodium formate has got equal resonance structures. Whereas in the formic acid, though it is showing the resonance structure, one side double bond is more concentrating, many times this, less times this. Let us say 75-25 arbitrarily, if I say, more times double bond, one side concentrating. Therefore naturally this side will be shorter, this side longer will be there. So the bond lengths are not identical. X-ray crystallography or certain the information data shows that the double bond and single bond, they are not identical length. There it is identical, because it is identical structures are there. So like that the phenomenon of resonance, both are showing resonance, but this is the better resonance than this one. Grade 3 always want to become into grade 2. Similar the case with the phenol also we can give this explanation. A phenol will have a original structure like this. We have a comparison of this structure with the alcohol, let us take. So basic skeleton structure of the ethanol and phenol both have a OH group. O has got a more capacity to pull the electrons, so therefore O can pull the electron and leave the proton. So therefore there is a chance of giving the proton in both the cases, because O is electronegative and the H plus may become like this, right? So there is a chance of here also. But what is the consequence of that donation? Let us see. Here also ethanol may become into ethoxide anion and the proton. This is called phenoxide anion. Phenol will give a phenoxide anion or ion. This is ethanol gives a ethoxide anion. So both have got this oxygen pulling capacity, therefore imagine that the both have given the proton. Okay. So now we have to, how best it gives the proton depends on what is the consequence of the donation of the proton. After donation, the phenoxide has a beautiful resonance. The O minus can be given like this. The double bond goes to here and becomes ortho minus. If ortho is given, para minus. So minus charge can go on delocalized to ortho, to para, to ortho, to comes back. So total how many structures? 1 plus 3 resonance. One is this one. The second one will be the minus charge here. Third one minus here. Fourth one minus. So 1 plus 3 resonance structures are there for the phenoxide. So therefore the process is ready process, and therefore phenol gives a proton, right? But whereas in ethanol, you see, ethanol also oxygen is pulling, therefore it may liable to give like this. But still, when you compare this one, that end here, phenoxide has a resonance stability. Ethoxide has no resonance because negative charge is there, but there is no double bond. Only negative charge cannot show without double bond. And moreover, the alkyl group we have already examined, it shows a plus I effect. So if it shows plus I effect when attached to the oxygen, already oxygen is having a excess electrons, and this ethyl group, if it starts to donating the electrons through the sigma bond, the minus charge is problem. The problem is increased because this is also giving. So therefore the problem is increased, means it get destabilized. So phenoxide ion is stabilized, right? It's stabilized through the resonance phenomena. It is destabilized in fact. Why it is destabilized? Through the plus I effect, because this plus I effect increases the minus charge and destabilizes. That's why this process never takes place. So a fair question is now, phenol shows acidic property, ethyl alcohol shows not acidic property, but both have this functional group. What is that? Hydroxy, HO, both have hydroxy function, but this shows, that's why this compound readily reacts with NaOH and forms a sodium salt. But there is no reaction between the sodium hydroxide and ethanol. Ethanol will not have any reaction with sodium hydroxide. Sodium metal however react, but with sodium hydroxide there is no reaction. This is acidic, therefore it reacts with sodium hydroxide, forms a sodium salt. Why it is so means, in the case of phenol only the anion formed has a resonance stability, therefore it is readily gives proton. In the ethoxide has no resonance, moreover another negative factor is also there, it has a destabilizing feature also, therefore the reaction will never takes place, or the donation of proton from ethanol will be very very meager amount. So that's why the ethanol considered to be almost a neutral type of the not acidic compound you can consider.